Okay, good evening everyone. We are here today to present you this bird of a feather called a Common Development Framework from JSP to GSP at CERN. How many of you know what is CERN? Or is here, and how many of you is here because he wants to know more about CERN? Just that. Okay, that's great. We were suspecting this. Okay, so basically today we are going to present you the work we have been doing the last 2 years in a project called AIS-20 Framework. AIS is the Advanced Information System section in which David and I belong. So he and I, we will present you the different topics today. And basically this is an effort that we have took a couple of years ago to improve the service we provide to the rest of the CERN. So CERN is the European Laboratory for Nuclear Research, and basically it's a physics laboratory. So from the IT point of view, we basically provide services, and we specifically administrative services. So as part of that, this presentation is only focusing on our work. So there are many projects at CERN that deals with Java technology and with other technologies, but here we will only see the technologies we use and how we use it in this technological framework. So the objectives of the session are just to provide you just a technical vision on how we faced these problems a couple of years ago, because it's not like one day you wake up and you think, well, I have to do a framework. We had some problems in maintaining the applications, and some problems when organizing the things, just because it was not consistent at that point. The options that we took 20 years ago to develop the software we have are not any more valid. That doesn't mean that the application doesn't work. I mean, all the applications work and they work fine, but we want to update ourselves to be able to face the next 20 years. So probably in 20 years we will be here again, talking about some other technologies. Who knows? So we will give you this overview of the Java technologies we use, and in particular, in the objective 2, you see Grails and JWT. Not many people, as far as we know, or as far as we are concerned, are using these two together. But well, you will see that we use them, and we use them in an effective way. And so far, we are sharing with you this work here. And at the end, if we have time, we would like to discuss with you guys about the opportunities that are offered on top of the JVM to work with some other languages as Groovy, which is the core of Grails, but also Clojure and Scala. We have been doing prototypes and try different things in order to have something really stable and mature to be able to put the applications in production. So far we have more than 5 applications using this framework, and well, we are happy with it. And this is how we are going to do it. This is a handmade graph. We still like paper, even though we are in 2012. So basically, as you see on the top left, we have CERN. Well, for those of you that want to know more, David will be giving a little introduction about what is the aim of CERN, what are its goals, and well, some specific data about the experiments and this big accelerator. And well, maybe at the end, if you want to know, we can answer you if we are going to destroy the world or not. In principle, we are not. Huh? And then he will be giving you also an overview on the technology that we have 20 years ago, that we still have, and what were the steps we took in order to come to this 3 point here, which is the framework. And here I will give you some specific data, information about what is for us this framework, what are the artifacts that we provide on it, to make it reliable and to ease the development processes in order to have a consistent approach in all of our applications. And in the end, as I said, we can discuss a bit what is your experience, if you have similar experiences with these technologies or some others, in the issues we found when we create this framework, and I'm sure you find the same ones. So who we are? I'm José Bobes. I'm Spanish. I guess you guessed it by the name. I'm a software engineer, and I work for CERN now in the project planning and resource management section that basically provides a service to all the groups. So like that, they can plan and and know how much does it cost to have 2,500 staff members at CERN, for example. So we deal with the planning applications and so on. And you will know more details with David.
You hear me? Yeah? Okay. Good. Well, as Bob has said, I'm working with him in the same section, but I've been already working at CERN for the last 5 years, and before this I was working more in another framework actually to do the analysis of the LHC data. I'm going to give you a rough introduction to CERN so that you actually know the scope of the problems we have, and I'm going to give you an introduction of why we chose the path that we're going to introduce, and Boris will give you the technical details at the end. So this is the first part. I do this introduction way longer, many times, because I'm a guide at CERN, and I always like to ask one question is, how many of you heard of CERN the first time because of the Angels and Demons novel or film? Not many? That's good, because I get a lot of these.
Okay.
That's good. So basically I'm going to go through 3 points. First, I'm going to show you where it is, how big it is, what we do, and what sort of technologies we use at all levels, and then I'll be a little bit more specific on the software and the computing that we do. And then I will show you where we work and what are the sort of things that we actually do on the daily basis. So first thing, it's in Switzerland. CERN is an international organization, and it's set up it's based in Geneva and actually in France. I don't know if it's easy to see or not. Maybe I can point or something?
Yeah, the pointer is there.
No, it doesn't work. Well, you see the airport, you see the circle is easy to see more or less? That's the LHC that you might have heard of it, the machine that wants to destroy the world and all this stuff. And this is 27 kilometers long of the diameter. It's about 8 kilometers of perimeter, I think. And you see the small circles, if it's possible. Those are the 4 collision points. Those are the 4 main experiments of the LHC. There are more. And actually at CERN we don't only do the LHC, we do a lot more things. But this is the most famous one. And you can get a rough impression of how it is looking at the size of the airport. So CERN, what is the business of CERN? CERN main business is doing science, and it's all about physics, fundamental research. And basically what we do mainly is accelerate particles. So we accelerate them to a very, very high speed, and we basically give it a lot of energy. And then we collide these particles, and do you know the formula, the famous formula from Einstein, E equal mc squared? That basically means energy is the same as mass. So if you have imagine two protons in the case of the LHC, and you smash them, and they have one big energy and another big energy, the total sum is what's going to generate new mass. So we're going to have new particles that they don't exist. And for this, what we do is once they collide, we take a picture, like with a camera. And this we do it in the detector. Can you guys see the guy in the detector? So you can imagine the size of these machines, okay? And a detector, how it works, is basically like the camera that you have. That you take a picture of the thing, and you actually capture the energy. In the cameras you have, you're capturing light. But here you can capture radiation, or you can capture different things, okay? And I mean, looking at the size of the things, you can imagine that to analyze all the data in these collisions, you're going to need a lot of power, computing power. And this is one of the biggest challenges, one of the main challenges we have, which is the analysis of these data. I don't know if you are aware, but we already presented some results like a few months ago. And yeah, and the machine has been running only for a couple of years, 2.5 years, I think. So that's pretty fast. And what we have is something that we call the grid, which is a huge infrastructure. And we pass there the data to analyze, and it's going to distribute it over the world and then resend the data and the results. But that's a rough introduction. If you want to know more, I can always tell you if you find me in the corridor. So one of the things we do that we are very proud of is that we actually try to push technology to the limits. And we do this in several fields. You can see here that we do it in, for example, in cryogenics, where you have to keep the machine to minus 271 Celsius, which is like 2.7 Kelvin. I don't know if you are aware, because here you use the Fahrenheit, so I'm a little bit lost here.
Well, yeah, in the end we try to simulate the condition at the beginning of the universe. So
we need this because we need to actually do the superconductive, and this is the only place in the world where you can do this. And now you need it to be very, very cold. But also in software we do this. The grid is one example. Okay. So now a little bit of the organization where we are. CERN has an average number of people about 10,000, 11,000 every moment at CERN, and you have peaks of 15,000. And this is only the people who are working at CERN at that particular moment. We have a lot of collaborations with different institutions and universities, and we actually need to have a lot of administrative data. And this is the department we are in is the GS department, which is General Services, and as we are an international organization, we actually don't even have, if we have a fire, the firefighters of Geneva, they cannot come into CERN because they would be violating the rules. So we actually have our firefighters, I don't know which one it is, our firefighters there, that they cannot go into Geneva and the Geneva ones cannot come in. So we actually, just to give you an idea of the sort of things that we have to provide. And in our group, which is called AIS, it's called Advanced Information Systems, and we provide services, as Bob said before, mainly in the administrative field. We have 5 sections, and some of them do deal with the HR department, some of them do finance, and we do project management and actually experiment support. For example, one of the applications we have is done to actually plan the way we are going to deal with the technical stops of the LHC. So we say we're going to stop it for 2 weeks and we need the slots of work. This is what we have to change. This is the people who can go, who has received this radiation and that cannot stay for a long time, and so on, so on. And the most difficult thing is actually the workflow, because there is a lot of people who have to approve different things, and it's a lot of the coordination where we actually try to help. So, and in the frame of this group, we, as Bob said before, it's a group that is 20 years old. And one of the peculiar things of CERN is that we have a lot of people going in and out, and we have different projects and many technologies that are now merged that we use at the same time. So things are getting a little bit difficult to maintain, and for people who are coming, newcomers, it's getting difficult for them to learn all the new projects. And especially if you are changing all the time, it takes you time to be productive. So with a lot of the people who are in this group, we are participating in what we call the AIS 20 project, which is a project that is going to run over the next 2 or 3 years, I think, and it's been running already for 2. And we try to improve the services that we do. And one of the main outputs is this framework that is going to be not only a set of technologies that we will use, but also a methodology and a process that we will follow, so that we guarantee quality and that we guarantee that everyone does it the same thing in the same manner. Okay? So another thing we want to look at is if the 20 years choices that we've been doing are still valid and how we have to deal with the future. So now I'll go more into the technology part. It's only 3 points, and I'm going to show you what I said before, the past, what we have decided to go from now on, and then how we will deal with the processes. So the first part is the past. As I said, we have a lot of people coming in and out, and we actually try to let people bring the experience they have from outside. And we want to motivate them to actually use new things as long as they are valid. And the problem is that if someone stays at CERN for, let's say, 5 years, and they develop an application that is going to be running for 10 years, someone else will have to maintain it. And at some point, we have tools that have been running for the last 20 years. So we have really old technology that is still there. And the way we migrate this is not always obvious. So you can see that, for example, we have iBatis and Hibernate for the persistent layer, and we have different technologies on the client, and so on, so on. So we have decided to move to only 2 stacks of technologies. One is Oracle Application Express, and we have a lot of experts in this field. So we didn't want to throw away this, and we are using this software to create applications that are not going to be long-term applications. So they will be there for a few weeks, a few months maybe, and we can be sure that someone will be in charge of the whole life of the application. And for the rest, we will use a stack of technologies based in Java that Bob will introduce you to. So the last part I want to talk about is actually about the process and the methodology. We want to use in all the sections in our group, we want to use Scrum with the daily meetings, as you might have seen in other talks. We plan our sprints in 2-3 weeks, depending on the availability of the people. And then we actually encourage a lot of code reviews because, as I said, one of the main problems we have is maintainability and learning. So we think this is one of the best ways to do it. And we also have the continuous integration that we do in Bamboo. I'm doing a lot of free publicity of Atlassian, so I hope it's not a big deal. That we have it connected with Clover for code coverage, and we also connect all the software with Sonar. I don't know if you're aware of Sonar, but you can actually put different static code analyzers. One of the most important ones is the check style, so that we guarantee that when you change from one project to another, you more or less get the same structure and the same way of writing code. And then we also use PMD and find bugs. And the last thing I want to mention is that all the applications we have, or at least most of them, are being analyzed constantly, and we do it with Interscope. I don't know if you know Interscope, but it's basically you tell, okay, these services, they cannot last that much time when they execute, or we actually check that the application is running, and so on, so on. And we are starting to implement Splunk, which is a log analyzer. This is more or less the environment we try to move forward. It's almost there, but we still have to implement it in more places. And now Boris will continue with more technical details of the framework. Thank you.
Okay, so we move a little bit on. So as David says, one of the main artifacts produced in this AS20 project is this framework. And even though it's going to cover, I would say, 95% of the applications we do, there is still some proprietary code applications that deals with finance, for example, that we are not going to substitute because, well, it has been there for 20 years, it works, so nobody wants to touch that, you know, and it's working fine. There is a company behind, so it's fine. So here, basically, for the framework, we decided to go to a combination of technologies that we think are the best fit for what we have. But I must say that we have tried a lot of prototypes using many other technologies. So I will give you some requirements of what we wanted to do, the considerations to take into account when you want to go in this process of creating a framework, and then what we really call the AS framework from the technological point of view, which is the technologies plus the architecture, and a set of plugins that we have provided inside this framework to help the developers to create these applications. And then we will see some screenshots of the application we have, and well, I will explain you a bit what is the goal of them and so on. So basically, the aim of this project is to improve the development process. So when a developer comes and wants to create a new application from scratch, he already has the basic components that you need. Let's say the infrastructure components you will need in any project that we start when we are talking about Java, and well, in any other technology is the same, but this particularly applies to Java. Then the second requirement was to improve the quality and maintainability, because as David says, people is coming and going every 3 years or 5 years, depending on the contract. Well, there is also some indefinite contracts there, but many people go after 3 or 5 years. So the documentation and the knowledge is living with them. So then you go and you try to understand what is being done there, and you know, we always have problems like trying basically to understand what is in there. So we will also like to have the documentation in the same place, all the documentation in the same place, all the way we deal with support. I mean, everybody will do it the same way. And you know, just try to search this consistency. So what we did is basically we create some reusable components that are spread in these plugins, and we unify the processes and technologies. It has been applied to many sections already, but there is still some work going on. So the considerations for when you think in a framework, you should know that it's not just I take a set of patterns and we put them all together and that's it. This morning, these guys talking about anti-patterns, they were mentioning this, you know, like people just say, oh, it's very good to have patterns, so let's put them all together, right? So this is not how it works, and it's not just a collection of libraries. So we believe that we should do the things in the same way. So like when you see his code, then I will be able to understand it as fast as possible, because sometimes we have to really react to the needs of the laboratory. So a couple of years ago, last year, we were asked to do a project to plan the launch shutdown. So the machine, the LSC, is going to be shut down for 1.5 years, and they didn't have a tool really to plan all together, how the things were going to be. If there were going to be allocation problems, I mean, we have, a number of electricians, and they cannot be at the same time in the same place, So we've been asked to create a project, and we did it in 2 months with this, and now it's in production, it's working, So in the end, we were able to do it, So apart from that, we provide this platform, that provides generic functionality. That's it. And then here is the technologies that we use and the architecture. So, well, as you see in the picture, basically we have a lot of experience with Oracle, and we are happy with it. In fact, we migrated last year to version 11G. And of course, on top of that, we decided to go for the Java virtual machine, because we have a lot of experience on that. All the people which is part of the group, they know how to deal with it. I will say they have a good level of them, so it was no discussion on using some other technologies, right? Because we also have parallel scripts and some little things around, but we are trying to migrate everything here to this stack. Then for the server side, well, based on this, we wanted to keep with a language similar to Java, and that's why well, it's not just the reason, but this is one of the main reasons why we end up using Grails. How many of you know Grails or have tried Grails? Okay, that's very good. Okay, so you know that it's really a framework that allows you to do a quick web application, and it's really powerful and Groovy. It's a powerful language, so we have all the benefits from Java. When I say Java, it's because we say Java in Spain, but it's Java. So forget about that. So it's Java. So it also gives you the dynamic capabilities and some functional programming also. And well, no surprises here. This is what comes with Grails. So what we did is to enhance this with a set of plugins. And then for the client side, we choose GWT, Google Web Toolkit. How many of you know about this? Okay, less people than Grails. But well, basically, we believe that Google is going to be there at least a couple of years more, so that they will maintain this and they will not disappear. And if you don't know it, what you do here is you program Java classes that in the end, everything will be compiled to JavaScript and it will be sent to the client side. So then you can create a rich internet application really easy with this, and you can, debug and so on. It's really easy to deal with it. At the beginning, can seem to be hard. It seems to be hard to configure, but once you have it, it's really good. And everybody will be doing Java or Groovy in the server side. So it's really what we want, to have something consistent and as unified as possible. Then we also use some widgets from this library, which is called ext. Well, there's a JavaScript version which is called ext. So it basically provides you with a set of pre-configured widgets like trees and combo boxes and so on. So well, we did this, and we also put on top of that, we adapt some of these widgets and we create our own. For example, we had a combo box, but we wanted to select a location, an access point to the LSC, and there are more than 1,000 access points in there, so I will show you later. But we created what we call the AES bag. So it's a kind of combo box with some more features than a normal one. So this is what we have as the main architecture. And on top of that, we use these plugins. So everything started, because this is a good thing to know, is that everything started as part, once we choose the technology, there was the need to put it that even we had prototypes, we need to test it in a real project. And I think David mentioned this at the beginning. So we create a project based on this, which is called intervention scheduling. So when you, as the LHC, as any other machine, it needs to be repaired from time to time, and it needs to be upgraded. So we were asked also to do, only for the LHC, we were asked to do, a kind of planning tool for that. And what we did is to plan it was an internal project in our section, in fact. We planned several sprints, you know, like mixing the framework and the project. So in the end, after I think it was 4 or 5 months, we ended up with this application, and well, it was used successfully for this period of time. But then I will show you another one which is replacing this one, because it has been extended to also take into account the other facilities at CERN, as the experiments and, you know, some other facilities with the same purposes. As you see here, well, now we have migrated the first version of the framework, because when we started this, we had Grails 137 and GWT, it was the version 1x something, I don't remember exactly. But now we finished migrating this to version 2.1 on Grails and GWT 2x 3 weeks ago. So we are adapting now the applications and so on. And so far, I must say that this, I mean, once you have the infrastructure there, it's easy to migrate and it's not taking too much time. So now what we have is 3 core plugins, which are DTO, security, and tracking, and we also have these other 4, but we're creating more. I mean, in Grails, it's really easy. If you want to add modules and things to your project, you can do it using the plugins mechanism, and that's what we did here. So now we're moving forward. So what is the DTO? So far, you are still here with me? Yeah? Okay. So the DTO plugin. Well, as you know, Groovy objects and Java objects are not the same. So there is the need of transferring the information or communicate one to another. You can do this in many ways. You can serialize objects, you can send JSON strings. I mean, you can do it in several ways. But as we choose GWT, what we did is to create this DTO, which stands for Data Transfer Objects. And with a script command, we type Grails generate DTOs, and what we get is from the domain objects in Grails, we get a DTO object, which is a Java object. And with this, we send it to the GWT client. So it's really, we create this kind of object with some metadata on top of it that will help us with the field visibility, with the errors and the fetching. And we use these DTO objects to communicate between the server and the client side. So this is the first problem that you find when you try to join these 2 technologies. Then we also have a plugin for security. I mean, security is really important at CERN. We already have a big infrastructure and a really solid infrastructure in there. And we don't want, you know, in every project to start creating from scratch the security aspects of that, because it's risky and there's no need to reinvent anything. So what we did is to create a security plugin, basically adapting the Spring Security plugin, which is available for all of you in the Grails library. And basically we did a thin layer over it that allows us with some little configuration. I mean, this is really an abstraction of that. So with some little configuration, we can set what are the authentication rules and what are the authorization strategies that we want in there. So this is basically for the security. Well, in fact, we're now moving to the single sign-on, because we had a proprietary login system, let's say, inside the group for our applications, but now we are going to move to the single sign-on, which is implemented all around CERN. And for us, it's just going to be, we will have just to update the plugin, and that's it. This abstraction is already there, so all the applications will work just as that. And then, once you communicate with the client, I mean, we have the artifacts to send to the client, but we need the client to communicate with the server also. And, you know, in Grails you have the services, and then you have the controllers and the view. And if you get rid of the controllers, because to do this, we wanted to use directly the service. So what we did is to use the GWT plugin, which is available also for you. And basically, the idea of this is to be able to make this communication possible. And so what we did do here is we create, I mean, it comes with the plugin, but we enhance it a bit. So GWT plugin, that, what it does is to create the interface to be able to call the service. So with this plugin, you are able to call the normal Grails service as it was from a controller in Grails, let's say. Then with this plugin, we also provide a CRUD service, which is generic. So you can, for free, you can edit your modify or update your domain objects just installing this plugin. And then we also implement a command pattern for the conversation. So when you want to modify a person telephone number, for example, then from the client side, you press the button, you open the person, but then there is a conversation going on. So we start editing the object, then we modify the field, then you can save it or roll back and so on. So we implement a command pattern in there, and well, it works so far. And we also put in here the internationalization, because we wanted to share the messages between the client and the server side. No need to replicate this. So this is also in here. And well, here, well, we also put some widgets on top of this. And as you see, this is the one I was mentioning before. So this is a combo box, but there were access points more than 1,000. So you type the name here, so, and then it will come here. Well, you select it, and then it goes here. So when you have, I mean, sometimes when they want to do an intervention there, they don't want to go, you know, in 5 different web pages. So it's really important to have all the information in a view, you know. So that's why we created this. With this, I want to say that with this plugin, we are able to provide more widgets on top of what already GWT and GXT do to ease, you know, the user experience somehow. Then, apart from this, so we already have the communication, we have the objects to be able to transmit it, and we have the security. But as in any other project, we also have logs, and in this case, these are the web access log. So if you install this plugin here, then you will be monitoring all the GWT RPC calls to the server, so you know how much they take, you know at what time the users are using your application and so on. So this is the typical graphs we have there, and it's really useful when you want to do support. You know? And finally, we have here the tracking plugin. Well, for us, and I guess for everyone else here, it's really, really important to know what happened to the domain objects. Sometimes it's critical to know who was the one that approved intervention in the tunnel, because you know there are some security issues in there. We have cryogenics, we have electricity, we have many things in here, radiation, and it's really important to keep trace of all the modifications that are being done to the objects. So for that, we created this plugin. So you just annotate the domain object as tracked, and then as we all use the same database, we are able to create the DDL and the triggers. Then you execute that, and for free you will have all the versions of the objects and the graph of the object during the whole life of this, you know. And then we have some other plugins that are not needed always, but that are really useful, because as we already said, we work in an administrative, we work for an administrative department, so including human resources, finance, you know, and so on. So what we have here is this Excel plugin, because these people is really used to work with Excel. So they create, I mean, we define a standard format between them and us, and then they are able to send, you know, to send us the files, we process it and so on. Sometimes they don't need a web interface for that, or even they don't want it. Then we have also the deployment plugin, which allows us to configure what we want to deploy and where we want to deploy it. Because so far we don't manage our servers. There is an IT department at CERN that does this for us, and we just have our own plugin. Just you type it from the command line, and you are able to deploy this application pointed to the test database in the production service, for example. That makes no sense, but you can do it. And then we also have some integration plugins to deal with, for example, the electronic document handling mechanism that we have, and which is already working at CERN. So every document which is processed at CERN is going through this workflow and this system, which is called EDH. And from asking for some vacation days to buy a mobile phone, everything goes there. So we needed to integrate this in the new framework, and we did it through these plugins. So the conclusions here is that we will be enhancing this framework in the short term, providing more widgets and more ways to communicate, because some people now want to use some of our applications. So we are thinking about creating some facades to expose our services, but in a secure manner. Then it really provides a common way of doing things. So now I will show you, but just the visual part of the applications, but behind they all have more or less the same even bus, the same presenters, the same views. I mean, you can really understand quickly what is going on. It solves the common problems among the apps with these plugins, and we already use it, and it's in production. It can be also integrated partially in the applications, because you maybe don't want to change all the application at once. So we have some examples also of some parts of an application just using the framework, while the other is still using struts and old technology. I say old, but I don't say it's not good. I still like it. Well, here are just 4 application examples, and then we will be discussing, I guess, if you are not shy to do it. So here is the impact project, and basically is the tool we use to deal with the interventions in the tunnel. So as you see, some people call it the big form. In fact, it is a big form. All the information is here in one page, so no other pop-ups are going to appear and so on. And that's why we created this AIS bag, as I mentioned. And well, you have the username and all this UI now is more or less common in all the applications. You have the way to call for support, the way to check the help, the menus on the left, and well, more or less the look and feel of the application is going to be the same in all of them. So here, if you want to go and change an electricity cable, you have to go through here. Then you put the information in it, who is going to participate in it, when it has to be done, what are the hazards and the risk, and then if there is an approval process, then we can do it also through this tool. And this tool then is communicating to the access system. So based on this tool, the access system will let people enter in a certain room just because this has been approved by someone. That's why it's so important, the tracking plugin here. But well, this is an example, and this is working now, and it's working well, I will say. And now we have Plan, which is the tool that we were being asked. I mean, these black lines, I put them, okay, because the information there is confidential. So it's not like this, huh? But this is yet another tool also to plan, because in the other one we can plan, but we were not able to check the allocation problems. So here, if you need a group contribution, I mean, you can have your plan, but maybe you need from someone else. So here is where we do that. And again, you see we have the same look and feel, the same menus, the list, the forms. I mean, everything looks more or less the same. So once you try something and it works, well, I'm sure it will evolve, because now we migrate to a new version of GWT and GXT, and they provide more widgets, but basically this is what we have. And now, well, yet another one, which is PPTU, which is responsible, is here, David, and well, it deals with, it's a time control tool, and basically it deals with several projects. CERN is collaborating with many universities and organizations, and sometimes they want to, to input the time they spend in some tasks, and they do it through this tool. So here again, the security plugin comes into play, because we are opening this tool to these organizations, and we can really easily connect it to their LDAP and make it all work without having to change the whole system. And then finally, no, there is another one. Okay, this is the another tool which has partially integrated the technology, the framework, but keeps working with the old technology also. And well, it's just for managing the resources. In fact, this activity planning tool is managing all the resources. So with this tool, we can know how much does it cost to have 2,500 staff at CERN, how much does it cost to the LHC, for example, or how much does it cost to create the new, for example, linear accelerator, which is going on now. So everything is happening here, and part of this tool is there. I mean, part of the framework is in this tool, sorry. And finally, we are also playing with HTML5 and Canvas and so on, because one good thing about what we do in there is that we have this room to search and to play with some technologies and able to improve. So we have created this trend because, well, even if you don't see here, that you can, there's a tree on the left and then there's a big Gantt chart. We tried to do it with what was provided by GWT and GXT, but it was really slow. Once you have more than 1,000 lines, it really gets stuck. So, well, we have been playing around a bit with this, and this is also integrated in some of the projects already. So now, I hope you're still alive here. We would like you to discuss a bit. If you have any question, we are happy to answer. Yeah, go ahead.
Well, I was curious about the integration that you guys did between Rails and GWT. Is there integration or maybe have to look at yourself?
So the question was whether we are, you hear me? So the question was whether we are using an open source tool to do this integration, right? There is actually one plugin that is doing this, but we did it ourselves because we wanted to add extra information in the DTOs that we pass, which is basically to connect to the graphical user interface. We want to actually give information about security, and we want to provide some default classes that are generated automatically. So we do this on the way we pass the objects back to the client. Anything else?
Have more questions? No? You sure?
Yeah.
I give you this because
Available as open source? Are your Grails plugins available like as open source or for license or anything?
We are actually thinking of doing so, but it's still, we still are on discussion on a few decisions that we have taken. So I guess in a few months we will do so, but we don't have a date yet. But that's the idea, at some point to do that. There was another question.
Some other technologies that CERN has been, give for free, like the web, for example. So I think there are opportunities to do that, but has not really been yet decided. We are talking about this.
I've had a lot of problems with large client data on GWT and trying to walk through it. What kind of solutions do you have with that? Or have you really experienced it? Like it really takes forever because it's going through each one.
Well, one thing that we did when dealing with this big amount of data, for example, for the list and so on, when we send to GWT, we had the option to send, the whole object. So you have the domain object itself. When I mentioned the DTO plugin, remember? So we have the model, we convert it into DTO, and you can send the whole object itself, but then this is too heavy. Then if you want to do a list of 500 items, it will work, but I would say slowly. These components that they offer, they are not really fast. So what we did is to have a fetch strategy mechanism. So like that, if you want to present just 4 fields in this object, we just send that part. It's like if you have JSON and you just decide to send some part of it. So we did this fetching strategy, and like that we are able to present. I think we have 500 in the configuration. We don't allow you to show all the activities that are going on in the intervention. But you can see like a reasonable amount of information just sending the parts that you really need. And for example, for the Gantt, for the Tran that we saw here, we did it with a canvas. It was faster to paint it than to produce it using the widgets that you have in GWT and GXT. We had to do it because of that. So we experiment these performance issues.
Okay, guys, thank you so much. They are putting a little bit of pressure. Thank you for your time.
Well, yeah.